Alright, a brief introduction before starting the solution set. First of all, keep in mind that you have to draw upon all of your years of experience in order to work the problems on the Math ACT. Every problem requires a plan of action. You need to formulate how you're going to attack the problem. And you have to draw upon multiple years of experience. Seniors have an advantage because they've had more years of experience in math. The more levels of math that you take through your high school career, the better off you are on the ACT math section. Secondly, just working these problems alone today will not guarantee success on the future Math ACT. So, why are we working them? Well, one reason is you're getting used to the format and the time constraints that are involved on the math portion of the ACT. The second reason is, once you've worked through these, you'll see the mistakes that you've made, and you can be instructed on the concepts and the standards that are involved in each of the problems. You will have a better retention rate. You'll be able to understand and remember these things now that you've gone through that experience. So focus on the standards. They're extremely important for the math section. Take this back into your other courses as you go through school. As you're sitting in front of a teacher and they're teaching the standards and the concepts, learn the concepts well, especially in a math class. Don't just learn the trick behind the problem or how to press buttons on a calculator or how to enter something into a computer. Understand why the problem was worked the way it was and what standards and concepts are necessary in order to have worked that problem. That will help you on the ACT in the future, especially on the math section. Last, remember that the benchmark for the math section is a 22. You're not going to understand that today because your score can't be translated into a 22 today because you've only worked part of the test. But as you work the entire test, you want to be shooting for the 22 on that math section. The ACT organization has studied freshman college GPAs and have found that the ones that made a 22 in high school on that ACT ended up being successful in their freshman year of college. Okay, the ACT is not just a college preparatory test per se. It does get used only by colleges for an entrance exam, mainly by colleges just to see if you can get into their school and be successful. But the same skill set that is measured on the ACT is also being measured by your future employer. It's also being measured by the military. Are you capable of making it at the college level so that you can get these new jobs that are being created, so that you can move on to that technical trade school and learn a skill, so that you can move into the military and serve your country? Same skill set here, so shoot for that 22 and guarantee yourself future success. Do not get frustrated, though, if you don't get the 22. The test does not measure your work ethic in a one-day test. So keep up your work ethic. Work hard, do the best that you can, and shoot for the 22 and get as close as possible. Okay, problem number 1. We have 10 boxes of books being delivered, and all of those boxes have 50 books in them, except for the last box that is delivered, which only has 40 books in it. Alright, so these boxes are being delivered. I'm pulling them out here to show you the boxes that have 50 books in them. Okay, there should be 9 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the last box has 40 books in it. Alright, in your mind you could take all of that and add it up, or you could think about this grouping where there's all 50 books in each box as being 9 boxes times 50 books per box, or a total of 450 books. 9 times 50, 450. And this box right here, obviously, to be consistent, it is 1 box times 40 books per box equals 40 books. And of course, taking the 450 and adding to the 40, we get our final result. 450 books plus 40 books equals 490 books. and we are finished. There's our answer. But there's more behind this, concept-wise, that you need to understand. Because the next problem that you see may just simply be, instead of a word problem, it might be 9 times 50 plus 1 times 40 equals, and you fill in the blank. Well, obviously we know what the answer is. It's going to be 490, but do we understand the order of operations is the key concept here. Alright, so order of operations, something that's going to be important that you need to understand. It can be remembered in this expression. I'm going to write this out. I've heard students say PEMDAS before. I've also heard students learn it the way I learned it. That you take the first letter of this phrase, take the first letter out of every word. Please excuse my dear Aunt Sally. Now you can come up with whatever way you want to be able to remember the P, the E, the M, the D, the A, and the S, which obviously stand for the order of operations. That first we look at parentheses, and any groupings that have parentheses around them, we deal with what is inside of the parentheses. Secondly, we deal with anything that has an exponent. We go ahead and crunch out or calculate whatever needs to be done with the exponents. Thirdly, multiplication, and I'm going to abbreviate that, put a slash, division, and I'm going to abbreviate division, meaning that we do multiplication or division as we encounter them. And of course, as we look from left to right, just the same way you read a book, move from left to right and do the multiplication or the division, whichever you find first. Do them as you go from left to right. And then the final step is the addition. I'm going to abbreviate addition and subtraction. I'm going to abbreviate subtraction, SUBTR, subtraction. Okay? Again, addition or subtraction as you move from left to right as you encounter them. Okay? So taking this problem here, 9 times 50 plus 1 times 40, and following the order of operations, we don't see any parentheses, we don't see any exponents. Let's move to the multiplication or division from left to right. And we encounter multiplication first of all. 9 times 50, that was already crunched down here. We know it's 450. And then we encounter addition, but that's after we've taken care of all the multiplication and division. So we look to see if there's any more multiplication or division, and we see it. So we take care of the multiplication first. So the addition stays addition, and 1 times 40 equals 40. We already crunched that down here. And then we can move to the final step, taking care of the addition and subtraction. 450 plus 40 equals 490. Order of operations are important. Remember them. Okay, problem number 2. What is the solution of this equation? Anytime you're asked to find the solution, you're looking for the value of the variable. In this case, we're looking for the value of x. One particular way to work this out would be to take each of the answer choices and substitute them in for the value of x and see if they work. No, that one doesn't work. No, that one doesn't work. Oh, finally you get to one that does work. Okay, that's a quick way to work it. But you have to understand the concept behind this. We're trying to solve an equation, and if you think about a balance here, if everything's going to stay equal, it has to stay balanced. We can't have one side heavier than the other or one side lighter than the other. Okay, when we attack these types of problems, our goal is to get the variable all by itself. We want it to have nothing else added to it or subtracted away from it. We don't want to have anything divided into it or multiplied by it. We want it to be sitting all by itself. And there are certain ways to make this happen, and if you think about what's happening on a scale, or this balance here, it'll help you to solve and keep straight what's going on over here in this problem. If I'm going to get x to be by itself, positive 3.4 has to go away. Okay? The way you make things go away in mathematics is you make them equal to 0. So why don't I subtract away 3.4 so that it will now be equal to 0? But hold on just a second. If I subtracted away 3.4 over here, I just took something off of the side of the scale here. It's not going to be balanced anymore. So I better do it to the other side just so we keep it balanced. Okay, and that's the key concept there. We need to subtract away 3.4 on this side also. Technically, that's called the subtractive property of equality. But if you can just learn that you're supposed to keep things balanced, it'll help you. Did we meet our goal? Did we get the x to be all by itself? Yes, we did. Okay? That's equal to 0, and all we have to do is crunch this out, and we get our final answer, 17.87, as our solution. Keep everything balanced. What you do to one side of the equation, make sure you do it to the other. Isolate the variable, get it all by itself, and you'll be set to go. All right, problem number 3. Make sure you read it carefully. Recording the number of pesos spent each day in a table, and then we are asked to find what is the mean number of pesos spent per day. Now, mean is the mathematical word for average. As you are getting your report card or your average, you are getting the mean of all of the work that you've done. It's one way to think about it. Mean and average, synonyms. All right, taking the mean or the average of a set of data is very simple, but you better make sure that you know what the table is talking about. On a vacation, this is the first day of the vacation, second, third, fourth, fifth, and so on. This is how much was spent on that day, and so on. So if we're asked to find the mean number of pesos per day, then we're just simply going to take the number of pesos per day, add them up. 250 plus 100 plus 150 plus 100 plus 400, and divide by the number of items that you were adding up. Of course, there's 5. It's that simple. It's that straightforward. Okay, so we add up 250 plus 100 plus 150 plus 100 plus 400, and we end up with 1,000. And we divide by 5, and we end up with our answer, 200. All right, problem number 4. If A equals 10, then which of the following represents 8003? The best strategy to work this problem is to take the value of A, which is 10, and substitute it in to each one of these answer choices. And that's the advantage of being multiple choice. Your strategy here, set it up, work it out. Answer choice F, if we take 10 and substitute it in for A, and I'm going to put in parentheses what I'm substituting in, we get 80 plus 3. Following that order of operations again, we're going to do the multiplication first and then the addition second. We get 80 plus 3 equals 83. Well, that isn't it. Okay, so that's a bad answer. Move to the next one. Answer choice G. 80 times my A, which is 10, putting it in parentheses again, plus 3. All right, multiplication happens again first. That's 800, and then plus the 3. We end up with 803. Sorry, I wrote the correct answer there instead of 803. 803. That's not what we want. We want 8003. All right, didn't work. Move to the next one. And you can see the process here. But I do want to say something before moving on. If you have to do this and write it all out, you're going to run out of time to work these problems on the ACT math portion. So do some of this math mentally in your head to speed up the process, if you can. If you're having trouble doing it mentally, then do the best you can working through with a calculator or on paper, and try to work quickly. All right, answer choice H. We have 8 times. My A is being squared this time, so when I put it in parentheses, I got to make sure I square it. And then plus 3. Order of operations say to do parentheses first. Everything's been done there. Exponent next, so we got to take 10 and square it. All right, so we've got the 8 times 10 being squared, which is 100. Okay? And then that's plus 3. All right. Again, moving on, we see that we have multiplication first, and we get 800 plus 3. Again, that did not come out to give us 8,003. That gives us 803. So, we still haven't found our right answer, and that's where this is going to take too much time if you're not doing some of this mentally in your head, because they put the correct answer further down the line. All right, let's try J. 8 times, let's take our 10 to the third exponent, 10 cubed plus 3. All right, once again, just like we did in H, let's do the exponent first. So we're going to get 8 times 10 cubed. Now, if you're having trouble and you don't know how to put that in on a calculator, think about 10 cubed as being 10 times itself 3 times. 10 times 10 times 10. Okay? And then you can put that in on your calculator, and you know that that's equal to 1,000 once you get done. And then, of course, after we've cubed that, we add 3. And we encounter the multiplication again first. And then we add the 3. And we get our final answer, 8,003. And that's what we wanted. We wanted 8,003. So the correct answer choice is J. Okay, problem number 5. We have a bag, and it contains 4 red jelly beans. You don't have colored pencils here, so maybe just use an R to represent the 4 red jelly beans. 5 green jelly beans. Again, maybe a G for green jelly beans. And then we have 3 white jelly beans. Well, I can't draw in white, so I'm going to draw black ink here, a W to represent the white jelly beans. And it's saying if a jelly bean is selected at random from the bag, that means we're just going to reach in here. We're going to try to pull it out. And we're not going to worry about seeing what's in there. So random, grabbing it out, don't know what we're going to get. And we want to know the probability that the jelly bean selected is green. Well, one way of thinking about this is, since you know what's in the bag and you can actually see what's in the bag before you pull out, it was revealed as part of the problem, pretend like you've pulled everything out. Okay, so go ahead and just pull all of the stuff out. Now, I can't pull them out and show you that visually, so I'm going to write down as we pull things out. Let's pull out the greens first. So we have 1, 2, 3, 4, 5 greens. Let's pull out the reds next. 1, 2, 3, 4. Let's pull out the whites last. 1, 2, 3. Probability in this case is thinking about the overall, after you have pulled out everything out of the bag, how many greens do you have divided by how many did you have in the bag, period. Okay? So think of it like that. If you could perform the entire experiment and go all the way through to the end, your probability is equal to the number of, and you're dealing with greens here, because it's asking you for green. So you're going to put the number of green beans in there, jelly beans. Probably shouldn't say green beans because it's green jelly beans. The number of green jelly beans divided by the number of jelly beans that there are. Okay, so that's one way to think about it. If you were to just go ahead and pull everything out of the bag, your probability is, well, I have 5 green jelly beans out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 jelly beans. Okay, so 5/12 gives you your result. Now, you have to know the information of what's in the bag to be able to work this. Okay, so you're the one who set up the experiment. You've put stuff in the bag. You know how much is in there. And you want to report to the people what's your probability of getting a green so that they'll play the game if that's what you're doing. Okay? Keep that in mind. Probability, number of green jelly beans divided by number of jelly beans that are in there, period. A general definition, probability could be equal to the number of items available, okay, the number of things available that you are choosing, okay? Divided by the number of overall items available. Now, you got to make sense of this. I'm writing this in layman's terms. That means I'm just trying to make it a little more understandable for you. If the number of items available that you are choosing, well, I'm choosing green. How many are in there that are green? It's another way to say that. And then divided by the number of overall items that are available. How much is there that I'm having to deal with as I reach in there? And, of course, that gives us our 5 out of 12. All right, and if that still hasn't sunk in, think back to the original way that I worked this and ask yourself, what is the chance of me getting a green jelly bean if I know that there are 5 in there and I know that there's 12 jelly beans overall that are in there? And you would expect that if you pulled a jelly bean out of here and you did it 12 times, that 5 of those times out of the 12 you would get a green because you know what's in there. So that's what you're doing with probability. Probability, and a synonym for that, if it's easier to deal with for you, chance. Okay? Probability or chance. And the chance of getting a green was 5 times out of 12. Okay, problem number 6. We have an earring manufacturing company, and it has fixed costs of $10,000 per month. That means the business every month owes $10,000 to somebody or someone. No way around that. Just for being in business, $10,000 is what it's going to cost. And then, of course, we have production costs that are 60 cents for each pair of earrings. So one pair of earrings is going to cost, one pair times 60 cents, or 60 cents. 2 pairs are going to cost 2 times 60 cents, or $1.20. And so on, so on. We could move on down one more. 3 pair costs 3 times 60 cents, or $1.80. Okay, so depending on how many pairs of earrings we produce, we have extra expenses. And that's the variable that's going on here. The number of pairs is varying. So when it says if the company produces X pairs of earrings, X is the variable. So this is my X, and it's showing up right here also as I physically crunch out how much it's going to cost me. So look down here and make sense of what answer choice is saying, that the total company's monthly costs are represented by that answer. Okay? Well, how much are we going to have to spend each month? $10,000 right off the bat. Okay? And then we're going to add something to it. As we make earrings, we got a little bit more to add to it. So answer choice F is out because it's not adding anything to it. It's multiplying by X. That's not going to work. G's in because it has addition. H, J, and K all have addition. So they're still okay for the moment. But let's think about this. If I made one earring, then I would say that I'm making 1 times 0.60 or 60 cents more cost in producing that. Now I can't say 1 right here because that is going to vary. This is the variable, so it's not 1, it's going to be my X. Okay, that's my X. So X times 0.60. That's what we're looking for. Alright, and of course it was written a little differently. In the answer choice here, we can see that it's not X times 0.60, it's 60 times X. So this is the correct answer, J. Okay, problem number 7 is asking for what value of A will X equals 3 as a solution to this equation. It's kind of hard to understand at first, so be careful the way you read this. You're not looking for the value of X. We're looking for the value of A that goes in there so that X will be equal to 3. So the best way to work this problem is to think about it backwards and go ahead and make X equal 3 and solve what the A needs to be. Alright, so I'm going to rewrite the equation, and I'm going to substitute in my value of 3 for X. Okay, I've got to substitute it in there, and I've got to substitute it in there. So we get 3 plus 3 equal to A times 3 plus 9. Okay, simplifying this, 3 plus 3 equals 6. A times 3, usually in mathematics we write the coefficient before the variable, so I'm going to switch that around, 3 times A, and then plus 9. Okay, don't let my 9s and my A's confuse you. We'll draw those 9s with a little bit longer of a stem. Now, from previous lessons or previous problems, we've learned that we want to keep a balance and we want to isolate the variable A. So to keep that balance and isolating right now, I'm going to subtract away 9 from this side, and I have to balance and subtract away 9 from the other side also. That leaves me with 6 minus 9, which is negative 3, 3A, and 0. One more step and I'll be done. I want to isolate the variable A by dividing out the coefficient, 3. I have to do it on both sides to keep my balance. 3 divided by 3 is equal to 1, which I'm not going to write because it is understood when I have it times A. So 3 divided by 3 equals 1 times A, gives me A. And negative 3 divided by 3 equals negative 1. Remember, a negative divided by a positive is always going to be equal to negative. So the solution is C, or the answer is C, negative 1. A has to be equal to negative 1 if we want X to be equal to 3. This problem requires skills that you will learn as you go through your mathematics courses into Algebra 2 and beyond. The skills that are needed will be reinforced in those courses. So freshmen and sophomores, don't get frustrated if this is a very difficult problem for you. Juniors and seniors, you should be reaching the capability of being able to work these problems at this point, to formulate a plan of attack and to be able to recognize what might be the easiest way to work the problem so that you don't run out of time on the test. Alright, problem number 8. We have a quadrilateral ABCD. Its vertices are listed, and we know that those are in the XY coordinate plane, which I've drawn here below. Let me label my axes. We have the y-axis and the x-axis, and we're supposing that we translated 2 units to the left and 1 unit down. Translated has a synonym, moved. Okay, so we're going to move 2 to the left and 1 down to form another quadrilateral, A prime, B prime, C prime, D prime. So that notation there with a little apostrophe is what it looks like. It's read as A prime. So which of the following shows the coordinates of the vertices of the new A prime, B prime, C prime, D prime? So basically it works the way you think it would. A is going to go to A prime, B is going to go to B prime, and so on. A is at -2, -1. Now make sure you're very careful. I have seen my students over the years not move correctly on the coordinate plane. This first part of the coordinate is the x portion. The second part of the coordinate is the y portion. If you have a positive for the x, you move to the right. Okay, so maybe we'll just put a little positive sign over here. If you have a negative on the x portion, you move to the left. If you have a positive on the y portion, you go up. And if you have a negative on the y portion, you go down. Juniors and seniors have been working with this for so long, they understand it like the back of their hand. Alright, so freshmen and sophomores, plot these points correctly. Get to the point -2, -1. Juniors and seniors, you should already be there. On your graph, right there, -2, -1. Now that is point A. I could at this point go ahead and draw it B, C, and D and draw the whole quadrilateral, but I'm running out of time on the test and I need to move on. That's what you're saying to yourself. Let me take one point at a time and see if it works. Alright, translate. Move it 2 to the left and 1 down. Alright, so we'll take A. Try to move it 2 to the left and 1 down. 1, 2 to the left, and 1 down. We'll drop it. That's now my A prime. Where did it end up? Count the units. Going back, 1, 2, 3, 4 to the left. So remember, that produces a negative on the x of 4. And then we went down 1, 2, down 2. And of course, that's a negative also. So -4, -2. F is the only that has -4, -2 in it. So you can stop right there and you've got your answer. If you want to check the other ones, that's fine. You can. But you know that F has to be the correct answer. Stop there and move on. Alright, number 9. I was picking on the sophomores and freshmen on the last problem as if maybe they wouldn't be as good as the juniors and seniors, but everybody should know this. Slope equals rise divided by run, or rise over run. Another technical definition is the change in y divided by the change in x. This looks like a triangle, but it's the Greek symbol delta, meaning change. Alright, so when we look at this A to B segment, and we think about what is its rise and what is its run, and have to make an estimate, we can immediately rule out two of the choices, D and E, because they're negative. When we look at the slope of something, we want to be traveling as if we're coming to the right and moving. If you have to move up, you know that the slope is positive. If you had to move down, which we didn't, then the slope would be negative. So we can throw out the negative choices. Next, we got to look at the scale and figure out if it's going to be choice A, B, or C. Now, if I had choice A for my slope is equal to 4. Well, that doesn't make any sense. I mean, that's just showing a number. We need a fraction, so we need a rise divided by a run, and that simply can be done by dividing by 1, because 4 divided by 1 is still 4. So my rise in this case is 4, and my run is 1. Now, it tells us that the scales are the same on both axes, so that means as we move up and we move over to the right, we have the same divisions on our scale. Okay, so if I scale out the y-axis and scale out the x-axis, all of our divisions are the same. Okay, missed it just a little bit there. My spacing is about as good as I can get as I'm writing on this. I don't have a piece of graph paper, so it's an estimate. Did I rise 4 and run 1? Now, if the rise is positive, you go up, and if it's negative, you go down. Even though that's an oxymoron to say rise down, but if it's a negative, you need to go down for your rise. Well, I have a positive for my rise. Go up 4, 1, 2, 3, 4, and run 1, 1. That doesn't work. Okay, I ended up being right up here. I need to be at B. So A is a bad choice. How about rise 3, run 4? So if I try this, slope equals 3 over 4. Rise 3, run 4. Okay, rise up 3. Start here at A. 1, 2, 3, and run 4. 1, 2, 3, 4. Well, I didn't quite get to B that time. That doesn't work either. And it's got to be C. Rise 1, run 4. 1, 2, 3, 4. All right, it checked out. Think about that slope equal to 1 over 4, or rise over run. Okay, problem number 10 here. You have a truck that's got a leak in its radiator. And right now there are 480 ounces in the radiator. Now, we're not just asked to figure out how long it takes for this radiator to leak all the way out and be empty. We're also asked how many miles did we travel if we were going 35 miles per hour. So it becomes a two-step problem. And this is what most of the problems on the ACT will be. They won't stop with one answer. You'll have to use the answer you get to answer something else. So that's where we are on this. Now, it's really easy to figure out how long it takes for this radiator to leak out. You could keep track of this. You could say 1 minute later, we've leaked out 4 ounces per minute, so 4 ounces have come out. And then 2 minutes later, another 4 ounces have come out, because it says it at a constant rate leaks out. Now that's going to take a long time to figure out how many minutes it takes for it to leak out. So you can think about this as taking 480 ounces and dividing by 4 ounces per minute. And of course we take 480 and divide by 4 and we get equal to 120. And you would have 120 minutes as your answer. Now that's a little bit sloppy looking there. So let's make sure that we reinforce some of the stuff that you're going to be doing in your science classes. Something you should have been learning already this school year, or have learned this school year. And that is called dimensional analysis. Now, dimensional analysis takes any value that you already have, and it changes it into another unit So we have ounces as our unit right now, and what I would like to know is how many minutes does it take for this radiator to leak out. Now the only way I'm going to be able to get minutes is if I have a conversion factor that will help me convert the ounces into minutes. Now that doesn't sound like anything that you would ever know in your daily life. How can you take ounces, which is a measurement of liquid, and convert it to minutes? Doesn't make any sense. Okay? Well, we do have a conversion unit in here. It says 4 ounces per minute. Anytime you see the word per, that's a key in on that you have a conversion factor. And conversion factor means I've got to put that here so that it will convert ounces to minutes. Now, I want to always be careful to make sure I put the part of the conversion unit that will cancel out with this unit here. And I'm dividing that out, so I want it to be in the bottom. I have ounces and I have minute. And it says 4 ounces, 4 per minute, per 1 minute. You can put a 1 there if you want to. Alright, so my unit is going to end up being minute. And that's what I wanted. My number that goes with the unit is going to be 480 times 1 divided by 4. Now that's equal to 120. So 2 ways to get it. Mentally kind of think it out, or use dimensional analysis. Alright, so it takes 120 minutes for the radiator to leak out. Now how many miles did we travel? Okay, if we've got 120 minutes now, and I'm trying to convert to miles. Okay, how many miles did we travel? Do we have a conversion factor that will help us go from minutes to miles? Well, not in the problem. It's one more little thing that you have to do, because we don't have just one conversion factor here. We've got 35 miles per hour. Okay, I mean that sounds like we could go from hours to miles. Okay. So if we had 35 miles per hour as a conversion factor, it'd be nice if we could just say that this canceled out, but we can't. Hours and minutes do not cancel each other out. So there's something missing here. And what's missing is a conversion factor that's not listed in the problem. You have to know that there are 60 minutes in 1 hour. And that becomes another conversion factor to help us get our unit into miles. Now, what I call this is baby stepping your way towards the unit that you desire. Minutes will cancel out, but we created hours with this conversion factor. But that's okay, because we have another conversion factor that will cancel out the hours and give us the miles as our unit. That's what we wanted. It took a little baby step to get there. You could skip the baby step if you just knew that there were 2 hours, okay, in the 120 minutes. Alright, now it would take care of itself there, but baby stepping our way towards it, we now have our final answer. If we take 120 times 1 times 35 and divide by 60. Okay, so 120 times 1 times 35 and divide that by 60. And of course that equals 70. Your answer, J. Other ways to work this problem are probably quicker, but this illustrates dimensional analysis, which will help you across curriculum, especially in science, as you work towards being successful on the ACT on those sections as well.